I'd like to talk right now about changing the type and the value of one of your numbers. So let's see what we're talking about. If I write double total equals 14.2, well, that's perfect, isn't it? Because the compiler sees 14.2 as a double. I'm assigning it into a double variable. Everything works perfectly. If I write double sum equals 5, well, that actually works just fine too, because the compiler reads the 5 as an integer, and an integer is much smaller than a double, so that I can assign it into a double without a problem. Here's where we run into an issue. If I say int number equals 14.2, well, the compiler says 14.2 is a double. An integer cannot have any decimal places, so I'm going to have to throw away the 0.2. It will do the conversion for you, and the answer will be number is equal to 14, no decimals. However, the compiler gives you a warning that you have a possible loss of data. Well, in order to get away from this, what we have to do is tell the compiler we're really serious about this. So what we're going to do is explicitly cast our number into an integer. The kind of cast we're going to do is called a static cast, and we use the little arrow operators, and we're going to cast the number into an integer. In parentheses is what we're casting, and in this case it's 14.2, or we could have put number in here. We could have put a variable in here. At any rate, the answer will be the same. Number will be 14, and it'll be an integer, but you won't get a nasty note from the compiler. This is what we call compiling clean. Sometimes we do our calculations in a floating point number, but we really want an integer as a result. You would have the same problem if you tried to assign a double into a float. Why? Because a double has twice as many decimal places as a float, and the compiler would warn you of possible loss of data again. Okay, so static cast is something we're going to be doing a lot of in this semester. The other thing I wanted to talk about was the cmath library. The cmath library, which used to be called math.h, is a built-in library with C++. So we used to have to pound include it, but I believe it's included with IOStream now. So if you're using IOStream, you don't need to include cmath. If you want to read more about the cmath library, I would suggest you go to c++.com. It is one of my favorite sites, and it has a lot of good information about the library. Now, suppose I take my numbered total over here, which is 14.2, and I want to square it. Well, I can certainly simply multiply total times total, and that is total squared, no problem. Well, what if I want total to a power that isn't an integer? Suppose I want it to the 1.6 power. Then I need to use the pow function of the cmath library. The first argument in this function is the number that is the base, and then 1.6 is the exponent. I can also take the square root of total by using the square root function. Again, here is total, and here is the square root function that comes from the cmath library. Now, there are some other very handy functions you can use. One of them is called the ceil function. Ceil means ceiling, And what that means is it will give you the ceiling of 4.2 or the next whole double number from 4.2, which would be 15.0. You can also use floor. Floor will give you the lower number, which is 14.0. And you can round it. There's a round function. This is from C++11. And if it's closer to the floor, it'll round it to the floor. And if it's closer to the ceiling, it will round it to the ceiling. So these are some very handy functions to have, and I believe we'll be using them in Program 1. So I just wanted to make sure you had them.